Today, the lecture to be done is quadratic equations. To talk of a quadratic equation, you see like this. When x is a variable in the sense a changing value, think of an expression like this, or as an expression like this, or is an expression of the form 3x square plus 5x plus 7. The index here is 1. The index here is 2. The largest index, say 7x square, 5x square, 7x plus 4. The largest index is 3. When it is index 1, you call it a linear expression. When the index 2 here, you call it a quadratic expression. When the index is 3, you call it a cubic expression. Today, we are to talk of these quadratic expressions. Look here. I write a quadratic expression of the form 3. Now this is a quadratic expression. Now whilst walking this way, I put a 1 here, it becomes a different expression. Whilst walking, I put a 1 here, is a different expression. Again, if I put a 1 here, it will be a different expression. I do some more changes, then it's a different expression, then it's a different expression, then it's a different expression, and then it's a different expression. Now, we want to consider a form, a way to express this generally. We use the English simple letter ax square plus bx plus c. Ax square plus bx plus c. It is said the general way to express a quadratic equation. It is said the general way to express a quadratic expression. The topic is quadratic equations. I am talking of quadratic expressions. But if this a becomes 0, 0x square plus bx plus c, then you get bx plus c is to power 1, therefore linear, no longer a quadratic expression. Therefore, when to denote a quadratic expression is important that we say this certain value a is not equal to 0. Then, if you are writing a note for yourself, say when a is not equal to 0. When a is not equal to 0, ax square plus bx plus c denotes a general form for a quadratic expression. Now this is a quadratic expression. We got to talk of quadratic equations. Then we say when a not equal to 0, ax square plus bx plus z is equal to 0 is the quadratic equation, the general form of a quadratic equation. This is the quadratic expression. When made equal to 0, you get the quadratic equation. The next topic. The roots of a quadratic equation. Roots of a quadratic equation. The next topic. You will go into smaller mathematics we done in smaller classes. Consider the quadratic equation x square minus 3x plus 2 is equal to 0. Now, I ask you, what do you mean by roots of a quadratic equation? Look here. Using small time mathematics, we'll put this into factors. You get x here, these two values, you get x square. I put 1 here, 2 here, these two values multiplied, you get 2. You take minus, then minus 1x minus 2x is minus 3x is equal to 0. Now for this to be 0, either it has to be x minus 1 is equal to 0 or x minus 2 is equal to 0, x is equal to 1, x is equal to 2. This is ordinary level mathematics. X is equal to 2. The roots of this equation. Now, when you mean to say these are the roots of the equation, I ask you the question, what do you mean by roots of a quadratic equation? Look here, is x is equal to 1? If this x is equal to 1, substituted in this equation, 1 square minus 3 into 1 plus 2 is equal to 0. When substituted, it becomes equal to 0. In mathematics, we say this value x is equal to 1 satisfies this equation. In the same manner, you substitute this here. 2 square is 4, minus 3 into 2, 6, plus 2 is equal to 0. Substituted, getting equal to 0, we say it satisfies the equation. The values of x which satisfies the equation are said the roots of the equation. If you are writing a note, write like this. They say values of x which satisfies the equation is said the roots of the equation. Now, when given an equation like this, you can find the roots of the equation. Now say, you are given an equation of the form 2x square plus 5x plus 1 is equal to 0, and you are asked to find the roots. And you are asked to find the roots. Look here. If you try to, you can't put this into factors. I'll just tell you how it comes. You put 2x here, x here, 1 here, 1 here to get this 1. Whatever the values put on here, you can't take the total of these products to be 5. Therefore, we use a different method of simplifying where we called putting to a complete square. Look here. First step is that we divide the complete expression by 2. Then, when you get x square, you get the complete root of it. You get this coefficient, you take half of it, and then you put it to a complete square. Then, simplified, you get x square, these two multiplied by 2. You know that a plus b square is what? A square plus 2ab plus b square. This value is square to the product. It becomes this value plus this value square 25/16. Where this 25/16 is not here. Therefore, we subtract. Then this part of expression simplified, you simply get this part. For the value you get more here, 25/16 gets cut with this. Plus half is equal to 0. Now, we want to find the roots of this certain equation. It comes like this. Look here. Is x plus 5/4 complete thing square is equal to these two values going to the other side of the equation. You get 25/16 minus 1/2. Minus 1/2. If you take 16 to be the common denominator, 25, 2 you get 8 of 2 here, minus 8. Then you get 17/16. Then x plus 5/4 is equal to square root of this. Then you get square root 17, 16, the square root is 4. When you write the square root, you got to write plus or minus. Then the roots would be x plus, the roots would be x is equal to minus 5/4 plus or minus root 17/4. From plus you get one root and minus you get another root. You get two roots. Then you write the next topic to be say roots of a not equal to 0, ax square plus bx plus c is equal to 0. Now look here, we want to get the roots of this certain equation. The first step is that you divide the complete expression by this value. Then the first step would be you got to divide the complete equation by this value. Then you get x square b/ax plus c/a is equal to 0. You got to say that a not equal to 0, unless of it you can't divide. Here it's not necessary to say that 2 is not equal to 0, because it is known, we know that 2 is not equal to 0. Here a variable value, we got to say not equal to 0. When it was x square here, we took x. When it is x square here, you take x. And when the coefficient here is 5/2, you took half of it. The coefficient here is b/2, you take half of it. And then take it to be the complete square. Then square of this value was subtracted. Square of this value to be subtracted. b square minus 4a square. This certain value was added, then this certain value has to be added. Then you get x plus b/2a complete thing square is equal to, these two values going to the other side, it becomes b square over 4a square minus c over a. Taking 4a square to be the common denominator, this b square remains minus, is a here 4a square, 4a more, therefore from that 4a this c is multiplied. Then you get x plus b over 2a is equal to, you get the square root of this value, b square minus 4ac divided by the square root of this value becomes 2a. Then the roots become, x is equal to this b over 2a going to the other side minus b over 2a, and surely when you take the square root you get a plus or minus here, then you get plus or minus square root b square minus 4ac divided by 2a. Then x is equal to, take 2a to be common, is minus b plus or minus square root b square minus 4ac. The roots of this equation, x is equal to minus b plus or minus square root b square minus 4ac. Probably in smaller classes your teachers would have given this to get memorized. Now it's a proof of it. You got, in advanced level mathematics, you got to have a knowledge x is equal to minus b plus or minus b square minus 4ac divided by 2a. That is, the roots of the quadratic equation are, one root would be x is equal to, you get 2a here is minus b plus or minus square root b square minus 4ac, or x is equal to minus b minus square root b square minus 4ac divided by 2a. The roots of the quadratic equation ax square plus bx plus a is equal to, x is equal to minus b, you took the plus value here, plus square root b square minus 4ac divided by 2a, and minus b minus, out of this plus or minus, plus you took first and minus you took the next. Now look here, you take plus 3, you square it, you get plus 9. You take minus 3, you square it, again you get plus 9. That is, you get the square root of plus 9, you get the square root of plus 9, it would be either plus 3 or else minus 3. You think the square root of minus 9? It does not exist a value for square root minus 9. That is, this does not exist, we call it imaginary. Now, there's a value within the square root. When the value within the square root is plus, this is real. If this is minus, this becomes imaginary. When this becomes imaginary, we say the roots of the equation are imaginary. Now, therefore, from this value b square minus 4ac, you can describe the roots. You can describe the roots. Therefore, we call it the discriminator and we give it a symbol delta in this certain subject, quadratic equations. Delta is equal to b square minus 4ac, where you call it the discriminator of the equation. Look here. 1. When b square minus 4 is larger than 0, then b square minus 4ac is a plus value. Then the roots become x is equal to minus b plus within the square root to get a plus value divided by 2a, comma, x is equal to minus b minus within the square root you get b square minus 4ac is a plus value, divided by 2a. When the value within the square root is plus, is real. When the value within the square root is plus is real, we say the roots are real. And it's plus here and minus here. The roots are real but different. Roots are, since plus here, minus here. The roots are real and different. We say, roots are real and distinct. We say the roots are real and distinct. Then, when b square minus 4 is larger than 0, the roots are real and distinct. Then we take the second option. When b square minus 4 is equal to 0, the roots will be x is equal to minus b plus square root. This value is 0 divided by 2a, or x is equal to minus b minus this value is 0 divided by 2a. Where square root 0 does not give a value, then the roots become x is equal to minus b over 2a, or x is equal to minus b over 2a. The roots are real and equal. We say the roots are real and equal. Roots are real and equal. Now, the third option we are to take is that when b square minus 4ac less than 0, b square minus 4ac plus we considered, b square minus 4ac 0 we considered. Then we got to talk of b square minus 4ac less than 0. So then b square minus 4ac is a minus value. The roots are x is equal to minus b plus within the square root value is a minus value divided by 2a, or x is equal to minus b minus square root a minus value divided by 2a. Minus value divided by 2a. Now, when is the minus value within the square root, the roots are imaginary. When there is a minus value within the square root, is the roots are imaginary, we say roots are imaginary. We say the roots are imaginary. Now, if we are to summarize what we were talking of, 1, b square minus 4ac, that is the discriminator, you call it delta, is equal to b square minus 4ac larger than 0. The roots are real and distinct. 2. When delta b square minus 4ac is equal to 0, roots are imaginary. 3. When delta less than 0, roots are equal to 0, roots are real and distinct. And this situation, the roots are imaginary. Imaginary. Look here. When b square minus 4 is larger than 0, roots are real and distinct, equal to 0, roots are real and equal, roots are real and equal. Roots are real and equal, the roots are real and equal. When delta less than 0, roots are imaginary. Then, taking these two situations together, real distinct, real equal, we say that is when b square minus 4ac larger than or equal to 0, real distinct, real equal, in the sense real, larger than or equal to 0, roots are real. Roots are real. That is, a not equal to 0, ax square plus bx plus c is equal to 0. the necessary condition for the roots to be real is b square minus 4ac larger than or equal to 0. Then the necessary condition when a not equal to 0, ax square plus bx plus a, the necessary condition for the roots to be real is b square minus 4ac larger than or equal to 0. When larger than 0, the roots are real and distinct. When equal to 0, roots are real and equal. Then keep in mind the quadratic equation b square ax square plus bx plus a. When b square minus 4 is larger than 0, the roots are real, distinct. Equal to 0, the roots are real and equal. Now, look here. The first question I give you is that find the largest value for k. Find the largest value for k which the roots of this equation are real. Now, you consider the equation x square minus 2x plus k minus 4 is equal to 0. You take a 1 here. This 1 acts as A, this minus 2 acts as B, and this k minus 4 acts as C. Now the necessary condition for the roots to be real is that b square minus 4ac has to be larger than or equal to 0. If the roots of this equation are real, when roots are real, b square minus 4ac larger than or equal to 0. b is minus 2 square, minus 4 times a is 1 and c is k minus 4 larger than or equal to 0. This would be minus 2 square is 4 minus 4 times k minus 4 larger than or equal to 0. Dividing the complete expression by 4, we get minus k minus 4 larger than or equal to 0. 1 minus k plus 4 larger than or equal to 0. 5 k. It is 5 less than or equal to k. Then k has to be less than or equal to 5. Therefore, the largest value k could take. Largest value k can take is k is equal to 5. The largest value k can take is k is equal to 5. And we'll go to the next question. Now, the question says, show that The roots of the equation x square minus equation x minus a x minus b is equal to c square are real. Now, what we know is that, the theory we know is that, consider the equation ax square plus bx plus c is equal to 0. The necessary condition for the roots to be real is this. Now, to talk of that certain equation first, we got to turn it to this form. Because what we know is that given this equation, for the roots to be real, it has to be this. So the first step is that this certain given equation, we got to turn it to this form. Then you get, simplifying this, you get x square minus ax minus bx plus ab is equal to c square, x square a plus bx plus ab minus c square is equal to 0. We put a 1 here. This acts as a. With the minus sign, this acts to be b, this acts to be c. Now, for us to show that the roots are real, we got to show that the determinant b square minus 4 is larger than or equal to 0. We would try to take the determinant of this equation, b square minus 4 is equal to b is this square minus 4 times a is 1 and c is ab minus c square. Now, to show that the roots are real, we got to show this determinant is larger than or equal to 0. Then, this minus squared, it becomes plus a square plus 2ab plus b square minus 4ab plus 4c square. We would simplify this to be a square 2ab minus 4ab minus 2ab plus b square. Then I would write this 4c square. Now we got to show that this is plus. We've got to show that this is plus. We'll try to implement this as a minus b complete thing square minus 2c complete thing square. This would be a plus value since it's a square. This would be a plus value since it's a square. Therefore, delta larger than 0, a plus value plus a plus value. Now, when talking the condition b square minus 4 is larger than or equal to 0, there's a condition it can be equal to 0 and still the roots be real. We'll just think whether this could be equal to 0. This could be equal to 0. We would say delta is equal to 0 when, look here, if A becomes equal to B or as B becomes equal to A, then this would be 0. A is equal to B is 0. And if this C is 0, then this is 0, this is 0, the total is 0, then delta is equal to 0. Then we know that the roots of this certain equation can be larger than or equal to 0. Say, therefore, the roots of the above equation are real. Therefore, the roots of the above equation are real. The next question would be, show that the roots of this equation are real. I would try this section, I'll start this section with simple questions and go to the extent of difficult questions little by little. Now say, you are given this equation and you are asked to show that the roots are real. You are given this equation and asked to show that the roots are real. But the theory we know is that when a not equal to 0, ax square plus bx plus c, the necessary condition for the roots to be real is b square minus 4ac larger than or equal to 0. But this equation is not of this form. Then the first step is that we got to turn this given equation to be of this form. Therefore, we will simplify the equation. Take the product to be the common denominator. From this x minus 1, this 1 would get multiplied. From this x plus 1, this 1 would get multiplied, is equal to 1 over c. Minus 1 plus 1 goes off. 2x divided by x square minus 1 is equal to 1 over c. You cross multiply. Let be x square. This 2cx brought this way, minus 2cx minus 1 is equal to 0. A better representation would be x square minus 2cx minus 1 is equal to 0. Look here, you put a 1 here. This 1 acts as a, with the minus sign, this 2c acts as b, and this minus 1 acts as a. Then, b square minus 4az would be b square minus 4ac would be b square. Look here, b is minus 2c square minus 4 times a is 1 and c is minus 1. This becomes minus 2c square is same as 2c square. Minus into minus is plus, plus 4. 4 could be written as 2 square. Is larger than 0. A complete square is plus. A complete square is plus, is larger than 0. In this situation, it does not become equal to 0 because this cannot be 0. The roots are real. The roots are real. Roots are real and larger than 0, distinct. The roots are real and distinct. Therefore, roots are real and distinct in the sense the roots are real. The roots are real. Now look here. This equation given, we first turned it to the general form. Then we took the b square minus 4ac value is larger than 0. The roots are real and distinct. The roots are real and distinct in the sense the roots are real. And the next question to be handled is that when a, b, c are real, show that the roots of the equation these are real. We'll try to consider this equation. Look here. Is the b minus c x square, c minus ax, a minus b is equal to 0. We'll compare this equation with the general quadratic equation ax square plus bx plus c. That is, this acts as a, this acts as a, this acts as b, this acts as c. Then we would take the discriminator delta is equal to b square minus 4ac. Is c minus a complete thing square minus 4 times a is this, c is this, c is this, a minus b, a, c. Now we'll try, now we got to show that the determinant is larger than or equal to 0. When the determinant is larger than or equal to 0, the roots become real. The necessary condition for the roots to be real is this b square minus 4 is larger than 0. We'll try to show, we'll try to see what happens to this. C minus a square, c square minus 2ac plus a square minus 4 times ba minus b square minus ca plus cb. Then you get c square minus 2ac plus a square minus 4ab minus into minus is plus 4b square minus into minus is plus ca minus 4cb minus 4ab plus 4b square plus 4ca plus 4ca minus 4ab. Now, we are in need of showing this that this discriminant is a plus value. Is equal to, I would take a square the first. The values are taken, I'll put a small undersign. Then I would take this 4b square. Then minus 2ac plus 4ca, is 2ac. 2ac. Then you get minus 4ab, minus 4ab, then you get minus 4cb. Now you got to show that this is a plus value. We'll just think of O-level mathematics. A plus b square is a square plus 2ab plus b square. A plus b plus c square. is a square plus b square plus c square plus 2ab plus 2ac plus 2bc. A square plus b square plus c square plus 2ab plus 2ac plus 2bc. If you try to implement this theory here, if I would take a square, the complete root of it is a. For b, the complete root is 2b. For a square plus b square, I have not taken this c square. Then you get minus 2, you get plus 2ac. A square, 4b square, c square minus 2ac plus 2ca is plus 2ac. From the c square, if I take the complete root and try to talk of the square of this value, either plus or minus here, squared you get this. Either plus or minus here, you get square. When squared you get this. Either plus or minus here, when squared you get this. Then it has to be 2ac, 2ac, 2ac. If I put a plus value here, these two multiplied by 2, you get 2ac. Then all the other two values are minus, I'll put minus here. These two multiplied by 2 would be minus 4. And that is, if I had to explain it again, these two, this squared you get a square, this squared 4b square, this square c square. These two values multiplied by 2, you get this. These two values multiplied by 2, you get 4ab. These two values multiplied by 2, you get 4cb. 4cb is larger than 0. A square, 4b square, c square, 2ac, minus 4ab, minus 4cb. And then the next question, can it be equal to 0? Yes. Here we will say here, delta is equal to 0 when a minus 2b plus c is equal to 0. A plus c is equal to minus 2b brought this way is 2b. B is equal to a plus c divided by 2. That is delta larger than or equal to 0. Therefore, you can write underneath, therefore, the roots of the above equation are real. The roots of the above equation are real. Now, when to explain this certain equation, it goes a little more beyond. Right underneath, consider the equation. B minus cx square c minus x, a minus b is equal to 0. Now, we try to study this question. You get the values a, b, c. Starting from this value is given b minus c x square, c minus ax, a minus b is equal to 0. The question started from the value b. You can rewrite the same question starting with this value. Right underneath, we can rewrite the same question starting from c, which will give c minus a x square, c minus a x square. Then you get a minus bx. Then b minus c. Totally the same question, but looks different. And also, you can write the same equation starting from a. Right like this. You can write the same equation starting from a. Then we get a minus bx square, a minus bx square, b minus c x, b minus cx plus c minus a is equal to 0, plus c minus a is equal to 0. For homework, you can try this and again try this. It comes to the same way I did before, but the question is different. All this is little different. It's the same form. So I was talking about quadratic equations, the most basic part of quadratic equations I was talking today. If you feel that you got some subject through this speech, I request you to please subscribe to my channel and also click the bell icon so that all the future lessons I put, you could get at once. And do please, if you feel that you are good with the subject, please give your comments about me. I like it. Whether it's good or very good or exquisite, or whatever it is, I know that it cannot be bad. So I'll meet you in the next video. From this place I stop. I'll have to do some 8 to 10 videos to complete the quadratic equation complete part, where you got to teach for advanced level or is a London level student for their knowledge. Thank you very much.